welcome back to another episode of Tech Talk Today, where we dive deep into the world of technology, data, and everything in between. Today, we're exploring an essential topic in the realm of databases, distributed systems. So, grab your headphones and let's get started. You might be wondering, what exactly is a distributed database? In simple terms, it's a database that spreads across multiple machines instead of being confined to just one. This approach has gained popularity for several reasons, and today we're going to break down the key concepts behind distributed databases, their architecture, and how they function. Let's start with why you might want to distribute a database across multiple machines. One major reason is scalability. As your application grows and the amount of data increases, a single machine can become overwhelmed. Distributing the load across multiple machines allows you to handle more requests and manage larger datasets effectively. Another critical aspect is fault tolerance. Imagine your application needs to stay operational, even if one or more machines fail. A distributed system provides redundancy, meaning other machines can take over if one goes down. This ensures high availability, which is crucial for businesses that rely on their applications being up and running at all times. Now, let's touch on geographical distribution. By storing data in various locations worldwide, you can serve users from the nearest data center. This reduces latency, so users don't have to wait for data to travel long distances. It's all about improving the user experience. Next, we'll dive into the architecture of distributed databases. There are two primary types, shared memory and shared nothing architectures. In a shared memory architecture, all components can access the same memory and storage, which can simplify some processes. However, this approach has downsides. As you scale up, costs can skyrocket, and performance may not double, even if you double the resources. Plus, this setup is limited to a single geographic location, which can be a significant drawback for global applications. On the flip side, we have the shared nothing architecture, which has gained considerable traction. In this model, each machine operates independently, using its own CPUs, RAM, and storage. This independence allows for better scalability and cost-effectiveness. You can add more machines as needed without the same financial burden associated with shared memory systems. Now, let's get into some complexities that come with distributed systems. When you distribute data across multiple nodes, you must consider replication and partitioning. Replication involves keeping copies of the same data on several nodes. This redundancy ensures that if one node fails, the data is still accessible from another. Replication can also enhance performance by allowing read queries to be distributed across multiple replicas. However, replication isn't without its challenges. When data changes, you need to ensure that all replicas are updated consistently. This is where different replication strategies come into play. The most common strategy is leader-based replication, where one node acts as the leader, processing all write requests while the others follow suit. In this setup, the leader writes new data to its storage and then sends updates to the follower nodes, which apply these changes in the same order. This method simplifies consistency but can create bottlenecks if the leader becomes overwhelmed. Another important aspect of replication is whether it's synchronous or asynchronous. In synchronous replication, the leader waits for confirmation from followers before considering a write successful. This guarantees that all replicas are up to date but can slow down the system if a follower is unresponsive. Asynchronous replication, on the other hand, allows the leader to proceed without waiting for followers to confirm receipt of the data. While this can improve performance, it introduces the risk of followers lagging behind, leading to potential inconsistencies. Now, let's shift gears and talk about partitioning, also known as sharding. This process involves splitting a large database into smaller, more manageable subsets called partitions. Each partition can be assigned to different nodes, allowing for more efficient data management and retrieval. Partitioning is particularly useful when dealing with massive datasets that exceed the capacity of a single machine. However, it also adds complexity to the system, as you need to ensure that queries can efficiently access the right partitions without causing delays. As we dive deeper into distributed databases, we also need to consider the transactions that occur within these systems. Transactions are crucial for maintaining data integrity, especially when multiple nodes are involved. We'll explore the various challenges that can arise in a distributed transaction environment and how to address them. It's essential to understand that while distributed databases offer many advantages, they also come with inherent limitations. These systems can be complex, and as a developer, you need to be aware of the trade-offs involved. For instance, while a simple single-threaded program might outperform a complex cluster of machines, the real power of distributed systems lies in their ability to scale and provide redundancy. In our upcoming episodes, we'll delve into specific issues that can arise in distributed systems, such as replication lag and eventual consistency. We'll also discuss how to integrate multiple data stores into a cohesive larger system, ensuring that complex applications can function smoothly. To wrap up today's episode, we've covered a lot of ground in the world of distributed databases. From understanding the architecture to the intricacies of replication and partitioning, it's clear that while distributed systems can be powerful, they require careful consideration and planning. Thanks for joining us on this journey through the complexities of distributed databases. If you enjoyed today's episode, don't forget to subscribe and leave a review. We'd love to hear your thoughts and any topics you'd like us to cover in future episodes. Until next time, keep exploring, keep learning, and remember, in the world of technology, there's always more to discover.